Hi, and welcome to Chapter 7.4 through 7.6. We're going to be getting into joins and order bys and wheres, which are just three different clauses that we're going to be adding to our SQL statements. Just a quick note, please, when you're reading the book, recognize in the notes section of this chapter, they talk about how some of the query types only work with certain DBMSs. So something might work with Oracle that doesn't work with SQL Server, or it might work with SQL Server but doesn't work with Access, and so on and so forth. I'm going to try to explain in some cases where that occurs, but remember, when you get out into the real world, depending on the DBMS that you're using might change the exact syntax of how to do the query, but all of these queries are going to be available as an option. All right, let's get started. So first off, we're going to revisit the from clause. So the first part of this, when we have a single table, we simply say select star from table name, which is fine. I'm going to refer to A, B, and C as my tables and field as my field names. I also have a little notation up in the top corner that says where we are working in that select statement. So we're going to keep building onto that box of select field list from tables. In this case, we're going to start introducing the word join. So when we have more than one table, there are different ways that we can reference it. If you do not need to link the tables, if the tables are not related together with a foreign key or any other kind of join in a relationship, and I just want to pull all of the records from one, and for each record that is in my first table, I want to put all of my possible records for my second table. I usually use the example of if I have three different options of meat and then three different options of toppings for a sandwich, and I want to find out what we call Cartesian product of those would be. So for each meat product, all the different options of vegetables or toppings. That's this type of thing. You can simply refer to that as a select star from A, comma B. We're not going to be doing this a whole lot, but it is one of the options that you have. So I wanted to make sure that I gave you that. Because most of our tables in a relational database are going to be related, we are going to be linking our tables. And so that's why this doesn't occur as often. So now we got that out of the way. Basic join. Assume that we have two tables, and those tables are related on a specific field. As you know from our ER diagrams, you know that there are specific fields. So I can have a customer ID from my customer table and a customer ID from my invoice table. And now I have these two tables, and they are linked on a specific field. In that case, I use the word join, and my syntax will be select whatever my field list is from A, join B, where A and B are my table names. And then I use the clause on, and the on is going to tell it what those fields are that are connected. In this case, I would do select star from customers, join invoices on customers.customer ID equals invoices.customer ID. So those field names in this case would be the same. They don't have to be the same. And you'll see in the examples that I'm going to use, sometimes they're not the same, and that's okay because the clause is going to tell the query which fields to attach. So if they're not the same name, that's okay. In the book, in this section, there are a couple of different ways that you can join. I'm giving you the examples for SQL Server, but in some cases you can simply reference the field name directly, just say on customer ID, and as long as customer ID exists in both tables, that works. Again, that works for some DBMSs, but not for others. I'm going to kind of lean you towards the SQL Server because that's the one you're going to be doing for this class. The way we look at joins, you can link more than just two tables. You simply add a secondary join clause. So the example I've given you here, select star from A, and then I'm going to join it with B on my field names, and then I'm going to join it with C on whatever fields need to be combined on C. Now the brackets in this situation are just for emphasis because I want you to see how those joins work. Okay? I'm going to go to the next slide, which is going to talk about different join types, and then we're going to give you some examples with SQL Server. Okay, so with our different types of joins, Our syntax in a join is going to be on a Boolean expression, and we can join different styles of join. So I want you to recognize the different ways we can describe these and how they work. The first is simply the basics between being an equality join or an inequality join, which we call an equijoin or a theta join. If you are doing a join and you are comparing two values directly, so field name A and field name B are exactly the same, they have to be equal, which is what most of yours are going to be. Those are regular equijoins. If we needed to use a greater than or less than, greater than or equal to, those are allowed as well. We're just not going to be doing them that often in this course. So those are called theta joins or inequality joins, ones that deal with inequalities rather than equalities. The normal join that you are going to be using in SQL Server is a natural join, or what we call an inner join. It only returns values where the equality is on both sides. So we don't return any excessive values. We only include values where both of those things are equal, which means there might be, if I said for all the student enrollments, and I wanted to compare students in enrollment, I wouldn't get any students who didn't enroll in any classes at this point because there is no enrollment record for them to match with. So this is a natural, or what we call an inner join. And sometimes we look at it as though it were a Venn diagram and we set all the records in table A and all the records in table B. This is only where those two records meet. So it's only where those equalities work on both sides. There is also the option of what we call an outer join. Again, the syntax for this is going to vary based on your DBMS. But an outer join can be either left or right, depending on which records you want to return all values from, and only those that match on the other side. So any fields over on the other side that you wanted to match would be returning null if there was no match. These are left or right outer joins, and they only the right or the left refers to what side of the equation on your equality statement. Again, we're going to be walking through this in just a second, so if I'm confusing you, it's okay. If you read the book or when we go through the slide, through the actual example, you'll see what I mean. There is also the concept of a full outer join, in which case it returns all values from both tables, and it'll have nulls for anything that doesn't match on either side. The last one of our joins before we show the example is going to be a cross join. This is, again, what we call a Cartesian product. It's where for each row in A, include all the rows in B. And it's in SQL Server, we don't call it a cross join, we just do from A comma B. Like we said in the previous slide, that's what you can do if you do not have to do any linking between the two tables. But there is in some other DBMSs what we call a cross join, and it does that same Cartesian product with a join. Okay, I'm going to stop talking for a second and I'm going to go over to SQL Server and walk you through what all of these mean and how they work, and then we'll come back.
All right, so at this point I have opened up my SQL Server and I am currently going to go in and do some queries. Now, for your homework, you are going to be using the clinic schema. So I'm not going to be using the clinic. I'm going to be using the tiny college. But I do want to kind of show you the different join types and how they work, so that you can see what SQL Server does and how it interacts. First thing I'm going to do is open up a new query. So I can right click on my database and just say new query from here. You can also click new query from up at the top. And it just looks something like that. It doesn't have anything done yet. So let's just do our first select query. Since we're going to be working with the tiny college today, I'm going to be doing the tiny college. Let's just grab one of them from there, and we're going to do a select star from tiny. And you can see as I start to type tiny, it should IntelliSense open, and I can hit tab to open that dot, and then it gives me the tables that I can pick from. So let's just look for the student. Semicolon, hit F5, and it should pop open your student table, which is nice because I can look at the student table and look at this. One of the things that I would like you to kind of do throughout this course as you're working with your ERDs and as you're building them, kind of keep a copy of them around. If you want to just like save it as a PDF and throw it on your desktop, or if you want to be wild and crazy and print it out and have it sitting next to you, having the ERD around while you're building your queries is kind of the point. You want to be able to have that ERD in front of you so that you know what those connected fields are, you know what the different fields are that are available, and how to get those. So having your ERD in front of you is a really useful part of building your queries. So let's start with our first join. In this case, we have classes and we have courses. So remember, we have a course. Let's go look and see what the course says. So I can come back here and I can go course and F5 and see, okay, so my courses are going to be a department code, a description, and a number of credits, and then, of course, my code, my unique identifier that describes my code. Comparing this back to Great Falls College, you'll notice that this is referring to a course directly, like CSCI 240, which in this case would be CIS 420, because they're going to make a 400 level course, but ours is 240. And then we have a couple of stats classes in there as well as some accounting classes. This is the course, but this doesn't tell you when the class was created. Because remember, we have another query, select star from Tiny College class, and the class one is going to reference the class itself for a specific semester or so on and so forth. By the way, that hotkey that I just did, so my cursor sitting here at the end, I hold down my shift key and I hit home, and that just selects everything in that row. Then I can just hit F5 from here and it will only run what is highlighted, which is kind of convenient if you want to have multiple queries that you're working with at the same time. I could always comment them out with a double dash like that in front of it, and that'll comment it out. Adding comments in your SQL queries, if we were to save them, is really useful. And in this case, I can just hit F5 without selecting it, and that's fine. But I like to kind of keep everything available. If I hit F5 with this uncommented, you'll see it'll run both sets of queries, which might be useful. That might be something that you want. Just a couple of options. So, looking at our class has a class code. Again, that CRS code, which is going to connect back to our course. What's section number? 1, 2, 3. When is it meeting? Well, they're all online. No, just kidding. What room that they're going to be in, and who the professor is. So that keeps track of these types of pieces of information. We have a professor number here, but at this point for Tiny College, I don't have a professor table. That's okay. I may add it in just so that you have it available as a piece of information. But for right now, for showing you this, we don't need it. I am now going to join these two tables together to produce one query that gives me all of the pieces of information that I need. So I'm going to come down again, and I'm going to go select, and I'm actually going to use star for now. I'll go in and I'll pick field names after. I actually like to pick field names last because I want to see all of my possible options before I go in and pick my field names. So then I'm going to go from, and I'm going to pick Tiny College .course, and I'm going to inner join. Remember, inner joins is where all of the fields have to be the same in both cases. This is also where you want to keep track of that mandatory versus optional that we talked about in chapter 4. Remember, if it's optional, you might have values that are in there that are not going to give you results. So that's fine. So tinycollege.class. So I'm going to join my course and my class. And I have to tell it on what? On what criteria? So I'm going to go on course.course code equals class.course code, because that's the field that's going to be combining between the two. Again, I'm just going to run that query, and you'll see that it gave me all of the pieces of information I need. I have my course code, department code, description, credits, and then it doesn't show you, but that's essentially where it stops. And then this is all the stuff that was related to the class. This is why I say I like to do this first and then figure out what fields I want. So now I can come back here and I can say, I want to do my course.course code. That wants to be one of them. Let's see. Let's do department code, course description, and then from our, let's get our credits, course credit. And then from our class, I want to know what my section is. So I can do class section, class time, classroom. And let's go ahead and get that professor, even though he's kind of useless for us now because we don't actually know what professor number goes with what. By the way, on visuals, you'll notice that I'm making things on different lines. I like to do this when my queries get long. So this was a kind of long query because there were a lot of fields in there that I wanted to select. So I wanted to select all these fields, and then I'll go ahead and hit enter at my from and get my tables that are connected. Every time I have an inner join, I want to put those on a new line, and I kind of tab it in just so I can visually see all of those. Okay, let's go ahead and run that. And you'll see it gave me a little bit less in the way of information, but those were just kind of duplicates, and we didn't really need those. So this still gives me everything I need to know for this semester, whatever semester we're talking about. These are my courses. I have accounting 1 offered 3 times, so I have 3 credits. One's Monday through Friday, one's Monday through Friday, one's Tuesday through Thursday, depending on which room they're in, so on and so forth. And it gave me that join of that. Remember, the joins are the most important part about SQL and relational databases. So getting comfortable with your joins is really, really important. This is your basic inner join or natural join. I only have records where they're the same. Okay. You can have a second entry here. So let's skip this one for a little bit and let's do one with students. So I can do a select star from Tiny College student inner join with tinycollege.enrollment on, and does anybody remember what they are? We're going to do student.student number, which is down here, equals enrollment and student number. You do have to tell it what table you want to use for both of those. I couldn't just do student number equals student number because the editor or the query will get really confused going, I don't know which table I'm referencing. So I have my select star. I'm going to go ahead and put in my enters here, and then I'm going to inner join that one. And then we're going to do a second one. We're going to do an inner join with tinycollege dot class on student, no, enrollment. Enroll class code equals class code. Okay. I now have linked 3 tables together. My 3 tables are student, enrollment, and class all at the same time. And we can hit enter. And as you can see, it filled in all the different possible fields I could possibly need. My students, all the information about the student that ends up right about here, professor number. The professor number in this case referred to like an advisor that goes along with a student. So that's my student field. Then we do our enrollment fields, which gave me a class code, a student number, and an enrollment grade. And then after that, I have my class fields. So now that I know all the fields that I want, I can come up here and I can change. I just want my student last name. I don't actually, I'll do the first name, student first name, because that's kind of a useful piece. I don't really care about their date of birth. I don't care about how many hours they have or what grade level they're at or their GPA, whether they're a transfer. I don't care what their major is. None of that's really important to me. Let's go over to what's their enrollment grade. And enroll grade. And then we can come over to our class. And I can get what is the class time, classroom, course code. That should be good. In class section. Oops, comma class section. And F5 that. A little bit more concise. So I can look at this and go, okay, cool. So these are, and actually, you know what I probably should have put in there was the class ID, because that's going to be kind of useful. Class number? Maybe. Let's go look at classes and find out what the class number was. Classes, columns. This is where having your ERD right in front of you. Class code. There we go. Class code. Having your ERD in front of you is fabulous. Okay. This is where it gets funny. You'll notice I have a little red mark underneath, and everyone who's ever done a programming class knows that that little red mark is bad. It means Cheryl forgot something. No, Cheryl very intentionally added in the class code at this point. And I'm going to hit that, and it's going to go, wait. Your column name class code is ambiguous. Ambiguous meaning that the computer cannot figure out which table's class code to use. Remember, we had the student, the enrollment, and the class. Well, there's a class code that's attached to enrollment, and there's a class code that's attached to class. I'd tell it which one. So I'm going to tell it, do the class.class code, and then it will be happier. I tend to pick the table in which this is a primary key rather than the table in which this is a foreign key in these type of situations. Technically, you could do either of them, and it would be fine. So now we have our last name, first name, enrollment grade, class code, class time, when did the class meet, what room were they in, what course was it, accounting, CIS, and then what section. Okay, so we know that William here is in section 3, Anne's in section 3, and then William here is in section 2, so on and so forth, and the grades that they have. So this is a 3-table inner join where everything is an inner join. Okay. This is how your basic joins work. And so getting comfortable with the idea of being able to use the phrase inner join. In some cases you can actually just use the word join. I like to put inner join just because, and those do exactly the same thing. Inner join clarifies that it is an inner join as opposed to an outer join. So I like the word inner join, but you don't actually technically have to use it. If you're just doing a regular natural join or an inner join, you can just use join. Okay. Now I want to show you how to do an outer join. I have a subset of students in this case. And I want to know all of my students. So I'm going to select star from my students, Tiny College student. And I want to join that with the enrollment. But I really just want to know which students are enrolled in classes, but I really want the list to have all of the students. So we are going to do and I'm going to show you the difference between them. We're going to start with a regular join. Join with enrollment. Tiny College enrollment. And we're just going to do that to begin with. And it's going to say, you forgot to do the on clause. On student number equals enrollment student number. There we go. Okay. This isn't all my students. I have like 6 students. And I can go check that by doing a quick select star from Tiny College. From Tiny College student. Yeah, see, I've got 8 students here. But when I did this query, I only get 2 students' names because only William and Anne have actually registered for classes at this point. I really want all of my students' names because I really want all the information about students, and then I want to know which ones have enrolled in which classes. So I'm going to do an outer join here with my student and my enrollment. By doing this, I have to decide, do I want to do a left join or a right join? So let us start with a right join. So we're going to call it a right join. I'm going to look at the data, and it's going to look exactly the same. Because the item that was on the right-hand side of the equation, which was this one, gave me all of the records from enrollment and only the records from student where they matched. That's silly. I really wanted a left join. You will find, until you get more comfortable with queries, you may not know off the top of your head whether you want a left or a right join, but that's where that ERD comes in. If you look at your ERD and you see which one was the one-to-many and which one was the optional and which one was the mandatory, that might help you with picking your left or your right join. So you can see here when I changed it to left join, it gave me all of my students and the ones who had registered for classes. So I know these are the students who registered for classes because they have a class code under their enrollment. These students with all of the nulls are telling me those are records where there is no enrollment for this student. There's nothing in the database for them. They haven't enrolled in a class yet. Tells me a little bit more about that, and that's how your left and your right joins work. Again, you also have the option of a full outer join, in which case it would tell you which students had not enrolled in any classes and which enrollments had no students. In this case, there can't be any enrollments with no students because that's how the enrollment table works. So we don't have to worry about that. The left and the right, you saw that the right join didn't give you anything different than the left join. So we can leave this as a left join. Just keep all of the records from student and only those in enrollment that match. So hopefully that gives you a little bit more example on left and right joins. Really an important part about databases is keeping track of that left and right join, remembering which one's which. Full outer joins we did, and then basic cross products, just to show you what that looks like. Again, we're not going to do a lot of them in this course, but if I did tiny college dot class and I did tiny college dot course, and I did not put any joins or conditions on that. That's what it looks like. What they have done is it has taken this course, Accounting 1, for 3 credits, and it has applied it to every class. So these are all the different class codes. So 112 through 124. And all of those are attached to accounting. And then we scroll down a little bit and we get Accounting 2. And we have applied 112 through 124 to Accounting 2. And then Intro to Microcomputing, and so on and so forth. So we've gotten a lot of this is kind of useless information because there's no attachment, nothing really is related. When we have a relational database, that's one of the reasons why we do it, is to have those relationships defined. All right, let's talk about the next slide. Okay, so you may have noticed when we were doing the queries that sometimes the table is a little long. And sometimes if I have to use the table name dot field name, that also can be kind of long depending on how long my table is and if I need to include my schema, and so on and so forth. What we do to solve that, to save ourselves time in typing, is we reference our tables with aliases. Now this is similar to the alias that you can use with your field names. Remember how we were able to change our field names from patient or student underscore number to ID, or student underscore L name to last name. You can do the same thing with your tables inside your query to reference them. One of the things that I like to do is to use either single letters or like acronyms for my tables. That way I can define my tables to be long and very descriptive, but when I write my queries, they'll make my queries just a little bit shorter and a little bit cleaner. So the examples that I've given here, first off, in SQL Server, you just have to add the alias after the name. It knows it automatically. In some of the other DBMSs like Access, you have to actually use the word as, just a heads up. Be careful when you make them to make sure that they're not too simple. Like I said, I like to use single letters, especially if I only have like 2 tables and both tables start with a different letter. I can just make them D and P and it works just fine. But if I have 2 tables that both start with a P and I make them P and P, then everything gets confusing. So I might call this one patient, PAT, and prescription, RX, or something like that, just to make my table alias short enough that it saves me time and energy, but still long enough to be descriptive. You can also use these in what we call recursive joins. So a recursive join is a situation where we have the table calling itself. We need to call 2 tables. Again, back in chapter 4, when you finish that one, remember we had the option of a single table where we had like a manager was associated with an employee, but the manager ID was actually the employee ID of the manager in the employee table. You can reference itself. So the example we've done here is select star from employee A being the table name of the employee, and we interjoined it with employee B. In this case, B is your manager. You could have called them EMP and MNG or something like that, instead of A and B, to make it a little bit more clear, and made it, employee ID is equal to manager ID, so on and so forth. Fix those. So table aliases are really, really useful when it comes to cleaning up your queries and making them really useful in that sense. We're now going to add another clause to our select statement. So far we have done select and we have done from. Now we're going to add order by. Order by is the sorting. So you'll notice that our record sets were kind of abstract in their ordering. Like, it may not have made any sense. It might have been sorted by ID, it might have been sorted by last name, it might have been sorted by date of birth. We really didn't have any way of defining how it was sorted. We're going to use our order clause to be able to sort. Obviously, you want to organize your record set so that the resulting record set comes out the way that you want it to. When you do your order by, you have to make sure, again, if you have ambiguous field names, you have the same field name in two tables, that you refer to which table it is. That's really important. You can sort by characters, or strings, numbers, or Boolean values, but all three of those work. And we can do both ascending or descending. The ascending order by is default. You don't have to say ASC. You can, but it's not necessary. Again, this is DBMS specific, so some DBMSs you might have to do that. For descending, it's usually DESC, descending, to tell us whether it's ascending or descending. Again, ascending would be A through Z, 1 through 10. Descending would be 10 through 1, Z through A, so on and so forth. You can have multiple order by options, so it'll be nested. Remember, we like the word nesting if statements, nesting for statements. We're going to do nesting order bys. If we have an order by, it's going to try to order by the first one first, and then it'll do the second one, and then it'll do the third one. So if we have 3 records that all have the same field 1, field 2 will then be sorted within that, and then field 3 within the field 2s and field 1s. So we can do nesting order by. Depending on your DBMS, null or empty fields might be sorted first, or might be sorted last, or may have to be defined. And we'll show that in the examples on how it handles nulls. So you need to be careful of those. Okay? So now I'm going to explain to you the where clause. First off, in your syntax, the where clause exists between the from and the order by. Clauses in SQL statements have to be in order. So it goes select, then it goes from, then it goes where, then it goes order by. You cannot put the where after the order by. You can't put the order by before the from. Everything has to be in order. Very, very, very important. You can have a condition, which is your where clause, which will be either your criteria or your restrictions, limitations on what your data was, or your criteria of picking out your data. Boolean expressions, assuming that you've done programming classes before, simply are going to be your field is equal to 5, your field is less than 15, it's equal to Joe, something along those lines. When you put it in, again, I put the brackets here just for emphasis, select star from table where field equals 5, and then order by field. So you're going to put it in the middle there. This is also why I like to put those new line characters. I'll put one at a select, one at a from, one at a where, and one at an order by, so I know exactly where each of my clauses are. You can have multiple conditions or multiple restrictions or multiple criteria as your condition list, as long as they are separated by either an and or an or. You do need to separate out those so that the compiler knows what, or the interpreter that is going to take your information in your query, your DBMS, so it knows how to process that piece of information. Again, you cannot be ambiguous in anything you do in SQL statements because it's all done by code, and it needs to be done that way. So I can say select star from table where field 1 is equal to 5 and field 2 is equal to Joe, and then order by field 2. I have quotes in here, but your quotes are going to not be necessary in your SQL statements. So the operators that you can pick from our basic Boolean operators. So your equals, your greater than, your less thans, greater than or equal to. Not equal to depends on your DBMS. Again, some of them use not with a exclamation mark and an equal sign. Some of them use a greater than or less than sign together. Some of them allow both. So if I remember correctly, I think SQL Server does allow you to use either for not equal. I tend to use the exclamation mark and an equal or the word not. So you can use the logical operator not as well. So you could do where not x is greater than 5, which is the same as x is less than or equal to 5. Also with comparisons on strings and dates, make sure that you put quotes around your literal value. Some DBMSs will use a pound sign for a date to separate out dates from strings because it handles dates differently. Dates are done just a little differently than regular strings. You can imagine a date can be written as month, day, year. It can be written as day, month, year. It could be written as year dash month dash day, depending on how it's done. So depending on your DBMS and the way that it holds date fields will determine how to write your query for that. But for SQL Server, we just use quotes. So it's pretty easy. By the way, a little piece of trivia. Before we had created joins, we would simply use a where clause with a Cartesian product or product between two tables. So remember, our select star from A comma B would give us that all of the values in B for each value in A. And then we just do a where clause where the fields have to be equal. As long as the fields are equal, then everything should be fine because those are the fields that are the primary and foreign keys. So those will help us to do that comparison. So you can always go back to an old style join. I wouldn't. I would just use joins the way that we've designed them. But those are always an option. All right. We're going to do one more slide. Okay. Our special conditioner operators. I am going to go back and show you a little bit more examples with order by and where, but I did want to explain special conditionals before I went in there. The book describes 4 of them, and these are the 4 that you're really going to need to know. I'm going to throw these into the homework assignment as well. So we can use the phrase between, which is simply a value that exists between 2 numbers. You could do select star from A where field 1 is greater than 5 and field 1 is less than 10. Same exact concept as between, except between puts it into one operation. So it uses the keyword between where field between, and then there should be a 2 numbers, 5 and 10, or however those go with your comparisons. So you can use the word between to determine between 2 numbers. We can use the in, and the in special condition operator is fabulous because we can actually say, is the value in a list or in a table or in another query? We'll get into those when we get a little further into SQL, but for right now we're just going to deal with the list. So you would do select star from A where field is in, and then in parentheses you would just write out your list, 1, 2, 3, 4, or 5. True or false, A or B, something like that. If we were doing our students in Tiny College, we might do what grade level they're at or something along those lines, like something that needs to be an in. Be careful with your data types because if you have your list as strings, but you're comparing against a number field or vice versa, you have your your field is a string, but your list is numbers, it's not going to compare correctly. So be careful with your data types. We have a special condition of like. Like is your wild card. Like is fabulous, by the way. We use like a lot. A percent sign simply means you can have any number of preceding or following characters. So in this case, you could do select star from table A, where the name is like Chris with a percent sign. That would return both Christopher and Christina and Chris and Christoph and any other thing that starts with Chris. So anything after that. But it has to start with Chris because we only put that percent sign at the end. You could put it on both sides, and then you would have to have a number that, or anything that returned either side of that. The underscore is exactly 1 character substituted. So if I said select star from A where name is, quote, underscore AT, it would return hat and cat and bat, but not brat, because that has 2 characters that are before it instead of just 1. So that wouldn't work. Again, depending on your DBMS, sometimes they replace the percent sign with a star, wildcard, and the underscore with a question mark for a single character substitution in like. SQL Server uses the percent and the underscore, so those are fine. But just remember, if you are working with other DBMSs in the future, that might come up. We also have the concept of is null. As you saw in the previous examples we showed you, if you did a outer join query, you might end up with some null values. If all I want to do is find things with a null, I can use the is null option. Remember, null means no value. There is nothing in there. It doesn't mean 0 and it doesn't mean a blank space. It is specifically the null value. Okay, let's go look and see what this looks like. All right, so here we are back at our tiny college. It is exactly as it was when I left you about 10 minutes ago. But now we're going to start adding in a couple of the things that we have learned. So up here we have a tiny college. Actually, that one's not really that bad. Let's just look at aliases real quick. So if I did select star from tiny college dot class, and I'm going to call that CLS, and I want to interjoin tiny college dot course, and I'm going to call that CRS, and I want to compare the on. I'm going to do CLS dot, and I can do course code, CRS code equals CRS course code. And you'll see that that should return the same thing that we did up at the top where we had the class and the course code here, but I was able to use that alias. So the alias kind of just makes my life a little bit easier because I only had to type in CLS here and CRS here, and I didn't have to type in the whole tiny college dot. I didn't have to type in course and so on and so forth. Sometimes your table names can get kind of long. Dependent, employee, customer, some of them get a little long. You can also do, if I just wanted to do a single query from tinycollege.student s where, and I can do s dot professor number is greater than, I don't know what they are, 100, something along those lines. And it gives me all the professors that have a number greater than 100. I think those are actually all of them, so let's make it greater than 200 because that makes a little bit more sense to show the where clause. There we go. So that's professors that are greater than 200, if that means something to you. We could even say the ones that are greater than 300 or 220-ish, and that'll give us some different ones there as well. So aliases, really, really useful. Order by. Order by is good. I'm just going to take that one out for a second, and we're going to come back up to this. Let's grab, how about this one? Let's look at that. So we have William and we have Anne, and we have their grades. What if we wanted to sort them by grade? So we're going to do an order by enroll grade. Enroll grade. Here. Now we have the A's, and then the B's, and then the C's. You know what? Let's order them also by last name. So Stu last name. And that will make sure that if anybody has the same grade, William will always come before Anne for the same grade. So here, where we have two C's and a C here for Anne, you can see we did this by ABC. And then within our C's here, we have our last name, Bowser, before Anne Smithson. And if we wanted to be wild and crazy, we could make this one descending and keep our Anne William thing the same. So again, Bowser's going to come before, but we're going to start with our C's, and then our B's, and then our A's. Okay, so that's how we can deal with our order by. Using our where, we did do our where before, but let's go ahead and look at, yeah, that's a good one. Actually, let's just do this one. There we go. Okay, so we have our tiny college and our classes. You know what? I just want to go find the classes that are, what should we do here? Inner join. I gotta get rid of that semicolon. And we're gonna do a where. Let's do where our classes meet on Tuesday and Thursday. So we're gonna say where class time is like that keyword like. And we're going to do a Monday, Tuesday, Thursday. Did I say Tuesday? Let's do Monday, Wednesday, Friday. Monday, Wednesday, Friday, and then any number of things after that. So we've done our Monday, Wednesday, Friday, and then everything after. So it should do this one, this one, this one, but skip this one. And you'll see that it returned just the ones that were Monday, Wednesday, Friday. Again, we could do the same thing. Let's go look and see what our possible options were for that. Let's say if we wanted to do the ones that were in a business classroom, so just a BUS, we could do the same thing. Where classroom is like BUS, BUS, and then a percent sign. And that will return only our business classes. What if we wanted stat classes? So we have our course here, but we've got statistics and we've got statistical applications. They're both in the CIS department, but we don't want the microcomputing and the database design. We just want our stats. So we're going to do where our course description is like, and we're going to do a percent stat stat with a percent. And this should return both our intro to stats and our statistical applications by using that like option. Okay, so that gives you our like. If we wanted to do our students who were in a specific grade, so let's do this list. We've got all these students, and I've got some date of births here. I've got some student hours. I could say where the student hours is greater than. Stu hours is greater than, let's do 80. And that'll give me students that are only over that 80. So they're actually, it's 90 to be a senior, but we could do is greater than 90, which would be senior level in grade points. And those are my 3 seniors. I could also say where my class, and you saw that those are in the student class as well. I could do my student class is in parenthesis junior or senior. And those will return just my juniors and my seniors. Okay, so these give you a couple of different things that you can do with your queries. We've covered our basic where clauses, we've done our order bys, our aliases, our ins. We didn't do between. Between you could do GPA. So we could do where, let's do our student where student GPA is between. Let's go 2.5 and 4.0. And that should return everybody. Let's do a 3.0 because we want to find out who's on the dean's list. So 3.0 and 4.0. And that gives us everybody who has a GPA in that 3 to 4 range. Okay. And then just to clarify, in case I wanted to check and make sure that I hadn't missed anything, I could just go back to hit that and say, okay, well, let's see here. This student, yeah, it looks like we did fine here because we just skipped these couple of students here. Okay, so that gives you in between like where you can set your where equals true or false. We had our student transfer here. So let's do and for our where clause because we want to get the students that are between 3 and 4 and student transfer equals true. So we'll say the ones that are transfer students that are between 3 and 4, and it's going to yell and it's going to go, what? I don't know what true is. You can usually tell if I get it right. Oh, student transfer is, oh, it's a varchar. That's even funnier. So it's not the way that it was set up. It's not set up as a true or false. I was going to say usually in SQL Server, true and false are actually a bit, so they're a 0 or a 1. In this case, it's true. So we're going to do as a string saying that it has to be equal to true. So Anne is our only student who is a transfer student who is between 3 and 4. If we did false, we could say these students, Walter, Raphael, and Gerard, are not transfer students, but they are also on the Dean's List. And as you can see, I can select everything except that last transfer just to make sure. And again, we get those 4 students, Anne, Walter, Raphael, and Gerard. Okay, let's move on to your homework for this one. Okay, please don't let this make you nervous. But yes, I am going to ask you to do 10 different queries. You're going to be using the clinic schema. So you may already have an ERD for your clinic schema that you did sometime in chapter 4. If you need help developing your ERD, please contact me and I can help you. It's not that hard. There's only the 4 tables. And you should be able to kind of see the relationship between them as you kind of look through the tables. If you don't already have an ERD, I would recommend that you scribble out quickly. These are the tables. These are the fields that are in the tables. These are the relationships between them. Are they going to be a one-to-many? Are they going to be a many-to-many? One-to-one? Are they mandatory or optional? Is there any criteria, cardinality that you need to keep track of, just because that will help you. What I have done here, because I'm cruel and evil, is I have just given you descriptions of the query. They are purposely phrased that way. I could tell you, run a select query that does this, but I think you can figure it out. So, for example, number 1 says get all the doctors who have written a prescription. Pretty simple request. You can imagine that if you were designing the application, that the customer would probably say, hey, I want you to get me all the doctors who've written a prescription. I've tried to limit these to get the first couple of them to understand how to do your joins, and then the next couple to start getting into sorting by, and then your where clauses, and then your special operators. So I tried not to add too much to each individual query. They're purposely phrased to have you come up with the answer. You need to use your best judgment to figure out which fields to show. In some cases, I have said you have to include the doctor's name, the drug name, and the prescription date. But please add more than that if you think that's necessary, if you think that would be something that the customer would want. You don't have to list everything, and I would like you to purposely limit duplications of fields. So as you know, when you join tables together, if you just did a select star, you'll get the same field twice because you'll get it in the first table and then the second table. You need to limit those. So you need to make sure that you only show appropriate fields. They should not be too verbose by having too many fields, nor too limited. Don't just give me the name, the drug name, and the prescription date, but give me a little bit more information as long as you have joined the doctors and the prescription. You may need to add a third table, for example, on number 1, which is why I'm hinting at you that you need 3 tables to get the pieces of information I've asked for. Each one of these queries you should be able to do. I've given you some hints, not all of them, and I've given you some limitations. Number 5, I want drugs more than $50. You should be able to do that, and that may not be too hard of a query, but if it does get too difficult, please use the team's discussion board to talk about it. If you have a question, you guys can all share knowledge. As long as you're not like, here, just copy and paste this SQL query, you should be fine. Make sure that you include in your homework both the query itself and the resulting record set. If the record set is more than, say, 10 or 15 lines long, you can just get the first couple of records, as long as there's about 5 or 10 records in there. Most of these are not that long because there's not that much data in the system yet. As we get further along, I'll probably tell you to limit it to a certain number of records, but for right now, that should be fine. Number 10 is designed intentionally of go figure it out. I've just given you a description. I want the information there. I want it how I want it sorted. You can figure it out. There's a where clause, there's a sort clause, there's fields, so on and so forth. Give me a call if you need anything. Please have fun with this. I mean, database queries can be fun. They can be a blast. Go in there, write them out. Use your table aliases as you need to. Number 3, by the way, is simply your number 2 query with aliases for your table names, just to make sure you know how to do the alias. The more you use them, the happier you'll be. Please contact me if you need anything. Have fun.